The Hubble Space Telescope has been in operation for over 34 years, proving to be an invaluable tool for astronomers and space enthusiasts alike. Originally not designed to observe objects within our solar system, Hubble has nevertheless captured extraordinary moments that would have otherwise gone unnoticed. Many planets lack dedicated missions, leaving vast areas of our solar system still unexplored. However, Hubble's sharp eye has allowed us to uncover remarkable celestial objects that continue to reshape our understanding of the universe. Beginning our cosmic journey close to home, we first examine our immediate neighbor, the Moon. Due to the Moon's large apparent size in the sky, Hubble cannot capture its entire surface in a single image. Other missions, such as NASA's Lunar Reconnaissance Orbiter, provide far better images of the Moon, making it more practical for Hubble to focus on other targets. The Hubble Space Telescope has been in operation for over 34 years, proving to be an invaluable tool for astronomers and space enthusiasts alike. Originally not designed to observe objects within our solar system, Hubble has nevertheless captured extraordinary moments that would have otherwise gone unnoticed. Many planets lack dedicated missions, leaving vast areas of our solar system still unexplored. However, Hubble's sharp eye has allowed us to uncover remarkable celestial objects that continue to reshape our understanding of the universe. Beginning our cosmic journey close to home, we first examine our immediate neighbor, the Moon. Due to the Moon's large apparent size in the sky, Hubble cannot capture its entire surface in a single image. Other missions, such as NASA's Lunar Reconnaissance Orbiter, provide far better images of the Moon, making it more practical for Hubble to focus on other targets. However, in 2012, Hubble played a crucial role in an intriguing event, Venus transiting in front of the Sun. Although the event itself was not directly related to the Moon, scientists used the Moon as a massive mirror to detect subtle variations in sunlight scattering through Venus's atmosphere. By analyzing these variations, researchers gained insights into the chemical composition of Venus's atmosphere. While Venus's atmospheric composition is already well known, this experiment helped confirm whether this method could produce accurate results. Hubble frequently applies this technique to study exoplanet atmospheres by observing distant stars as planets transit in front of them. Since the Sun is too bright for Hubble to observe directly, using the Moon as a reflector enabled scientists to obtain the data they needed. Unlike the Moon, Mars is a much more accessible target for Hubble's instruments. The telescope has frequently observed the red planet, offering a full view of its surface, something orbiting spacecraft cannot always achieve. These images have provided valuable insights into Martian weather patterns, including dust storms, seasonal changes, and other atmospheric phenomena. Such observations are crucial for planning future rover operations and developing accurate weather predictions. One of the most striking sequences captured by Hubble was a time-lapse of a global dust storm engulfing Mars, completely obscuring its surface. In the background, Mars's two small moons, Phobos and Deimos, can be seen zipping around the planet. Another time-lapse focused on Phobos, the larger of the two moons, capturing its movement over just 22 minutes. With Phobos completing an orbit around Mars in only 7.5 hours, it remains the only moon in the solar system that orbits faster than its planet's day. Beyond Mars, we venture into the asteroid belt, a fascinating region filled with numerous celestial bodies. One particularly intriguing asteroid is 6478 GT, a misleadingly named celestial object that appears to resemble a comet. Imaged by Hubble in 2019, GT possesses twin tails, a feature more commonly associated with comets. Scientists believe this phenomenon is caused by the Yarkovsky effect, where solar radiation exerts a small but steady force on irregularly shaped objects, gradually increasing their rotation speed. In GT's case, its 3.5 km wide body has been spinning faster over time and now completes one full rotation every 2 hours, pushing the limits of what an asteroid can endure. This rapid rotation generates centrifugal forces stronger than the asteroid's gravity, causing loose material to be ejected into space, forming the distinctive tails. Over time, GT will likely disintegrate entirely. Many asteroids, including GT, are not solid rocks, but rather fragile rubble piles held together by weak gravitational forces. The asteroid belt contains between 1 and 2 million asteroids larger than a kilometer and countless smaller objects, making it a dynamic and chaotic region. A remarkable example of this chaos is P2010A2, initially mistaken for a comet. However, closer examination of its nucleus revealed an unusual filamentary structure, which was later identified as the aftermath of a collision between two asteroids. The X-shaped structure near the nucleus consists of debris from the impact, with rubble being ejected in 4 directions. Some of the material is pulled back toward the center of mass by weak gravitational forces, while other particles escape entirely. Despite occasional asteroid collisions, most objects in the belt follow relatively stable circular orbits. However, if an asteroid strays too far from this path, much like a comet, it risks encountering the immense gravitational force of Jupiter. Jupiter, often called the solar system's vacuum cleaner, has a gravitational influence so strong that it significantly shapes the fate of nearby objects. With its immense mass accounting for nearly 34% of all matter in the solar system outside of the Sun, Jupiter exerts a profound effect on its surroundings. A striking example of this occurred in 1994 when comet Shoemaker-Levy 9 ventured too close to the gas giant. Captured by Jupiter's gravity, the comet was torn apart into several fragments. By the time these fragments impacted Jupiter, they were already scattered, marking the first ever direct observation of an extraterrestrial collision. Interestingly, Shoemaker-Levy 9 had been captured by Jupiter roughly 2 decades earlier, orbiting as an active comet until it was shredded by tidal forces. In 1994, its fragments crashed into Jupiter at an astonishing speed of 60 kilometers per second, 210,000. The resulting impacts generated fireballs reaching temperatures over 23,000 K, rising 3,000 kilometers above Jupiter's surface. The most significant impact left a dark spot spanning 12,000 kilometers, about the size of Earth, and unleashed an energy equivalent to 6 million megatons of TNT, more than 600 times the power of the world's combined nuclear arsenal. Observations of similar impacts lend credibility to the theory that Jupiter shields the inner planets from catastrophic collisions. In addition to its immense gravitational influence, Jupiter produces breathtaking auroras. Unlike Earth, where auroras appear sporadically, Jupiter's auroras are continuous and hundreds of times more intense. In 2016, during the Juno spacecraft's journey to Jupiter, Hubble played a crucial role in studying the gas giant's auroras by monitoring them daily for several months. The findings revealed that Jupiter's auroras are not solely driven by solar wind, but also by the planet's fierce radiation belts. Alternating currents within Jupiter's magnetic field contribute to the aurora's radiant energy, a phenomenon unique among the planets. Moving further outward, one of Jupiter's most intriguing moons is Europa, a prime candidate for harboring extraterrestrial life. Europa's surface is covered in a thick ice layer, but beneath it lies a vast subsurface ocean. The moon's proximity to Jupiter results in extreme tidal forces that generate heat, which likely keeps the ocean in a liquid state. Various missions have sought evidence of this hidden ocean, with Hubble playing a surprising role. Although spacecraft like Galileo and Voyager captured higher-resolution images, they lacked Hubble's ability to observe ultraviolet light. Hubble detected what appeared to be water vapor plumes erupting from Europa's surface, providing compelling evidence of a subsurface ocean. Furthermore, Hubble's observations confirmed the presence of sodium chloride on Europa's surface, suggesting that the underground ocean is chemically similar to Earth's oceans. Beyond Jupiter, Saturn remains another fascinating target. Since the conclusion of the Cassini mission in 2017, Saturn has lacked a dedicated spacecraft, making Hubble our best tool for monitoring the gas giant. The telescope frequently observes Saturn's atmospheric weather, including massive storms stretching thousands of kilometers. Moving even further out, Uranus and Neptune have remained relatively unexplored since the Voyager 2 flybys in the 1980s. Hubble has filled this gap by capturing seasonal changes in Uranus's atmosphere and discovering Neptune's smallest known moon, Hippocamp. Without Hubble, this tiny celestial body might have remained unknown. Observations like these continue to refine our models of solar system formation, providing valuable data about distant and largely overlooked worlds. Reflecting on these discoveries, it is clear that Hubble has been instrumental in expanding humanity's understanding of the cosmos. Over the past 3 decades, the telescope has achieved far more than anyone could have imagined, offering insights and images that will fuel scientific discovery for years to come. With proper maintenance, Hubble could continue operating until 2040, potentially outliving even the James Webb Space Telescope. The legacy of Hubble's mission reminds us to keep looking up because the universe still holds countless secrets waiting to be uncovered. The asteroid belt, with its chaotic population of 1 to 2 million asteroids larger than a kilometer and countless smaller ones, is a dynamic region. To illustrate this, let's examine P2010A2. At first glance, it appears to be a typical comet. However, a closer look at its nucleus reveals an unusual filamentary structure. Surprisingly, this is not the comet's nucleus. It isn't even a comet. What we're seeing is an extraordinarily rare event, a collision between two asteroids. The X-shaped structure near the nucleus consists of debris from the impact, with rubble being ejected in 4 directions. Some of this material is pulled back toward the center of mass by the faint gravitational pull, while particles in the tail have escaped entirely. Despite the occasional chaos, most asteroids in the belt follow relatively stable circular orbits around the Sun. However, if an asteroid strays too far from this path, as comets do, it risks encountering a far more powerful gravitational force, Jupiter. Often called the solar system's vacuum cleaner, Jupiter is a dominant force in this region. Its immense mass accounts for nearly 34% of all the matter in the solar system outside the Sun, giving it a gravitational influence that shapes the fate of nearby objects. A striking example of this occurred in 1994 when the 2 km-wide comet Shoemaker-Levy 9 ventured too close to Jupiter. The planet's gravity not only captured the comet but also tore it apart, breaking it into several fragments. By the time the fragments impacted Jupiter, they were already scattered, marking the first ever direct observation of an extraterrestrial collision. The impacts on Jupiter generated fireballs reaching temperatures of over 23,000 K and soaring an astonishing 3,000 kilometers above the planet's limb. The most significant impact left a dark spot spanning 12,000 kilometers, roughly the size of Earth, and unleashed energy equivalent to 6 million megatons of TNT, more than 600 times the power of the world's combined nuclear arsenal. Beyond its immense gravitational influence, Jupiter offers ethereal phenomena that captivate astronomers. For instance, Earth isn't the only planet to experience auroras. Thanks to the Hubble Space Telescope's ability to detect ultraviolet wavelengths, we've been able to closely study these dazzling displays on other planets. Jupiter's auroras are the easiest to observe, as the planet is not only the largest and closest of the gas giants, but also has a powerful magnetic field and intense radiation that generate incredibly bright auroras. In 2016, during the Juno spacecraft's journey to Jupiter, scientists seized the opportunity to measure solar wind en route and study its impact on Jupiter's aurora using Hubble. This collaboration revealed auroras hundreds of times more intense than those on Earth, with a radiant power of 100 terawatts. Unlike Earth's auroras, which appear sporadically during solar storms, Jupiter's auroras are continuous. Let's shift our attention to one of Jupiter's most intriguing moons, Europa. This icy satellite may potentially harbor the closest extraterrestrial life to Earth. Hubble has captured Europa in impressive detail, considering the vast distance. Europa's proximity to Jupiter results in extreme tidal forces, causing what is known as tidal flexing. This process generates heat, which scientists